So now we're recording it. And that's for the other classes because I'm not going to be at all my classes today. I'm gone in the afternoon today and tomorrow. So we have there's some review slides right there. Oh, I know it's going so slow because it's running video while we're doing this whole thing. All right. Well, that's all right. It'll work.
Can it hear what we say?
Yeah, I think so. Ooh, the slowness. The slowness. I'm gonna hide that. There we go. All right, so that should say kite. Two kids are flying a kite together. The difference in the angle of depression between the two strings is 22 degrees. One kid's string is 100 feet long and the other kid's string is 80 feet long. How far apart are they standing? The best way to use today would be to get a piece of paper out and to do it ahead of me instead of just watching me, because it's one thing to be able to follow along, it's another thing to be able to do it, right? I don't know how many of you experienced that, but I've stared at something and said, oh, I get that, and then the next day I'm asked to reproduce it. I'm like, I could understand that yesterday, but I can't write it down now. All right, well, let's try their tools here. So there's a kite. First thing you want to do is draw it, right? There's a kite. And there's two strings. What's the angle of depression? You remember what that means? That's the angle below the horizon. So if that's the horizontal, then this says the angle of depression between the two strings is 22 degrees. So we're going to have one string like that, and one string like that, and the angle between them is going to be 22 degrees. I think I'm going to be switching to the other annotation tool. This is giant pen and slow. And these two people are standing on the ground, right? One kid's string is 100 feet long and the other is 80. Obviously, the longer one has to be the 100-foot string, right? Good morning. And the other kid's string is 80 feet. How far apart are the kids standing? So how are we going to solve that? Can we use a law of sines?
Wait, how did you get that it was 20?
Oh, that should be 22. All right, this is already not happy. Switching tools. All right, so that should be 22, sorry. Do you have a tool to solve that problem? You will have access to those formulas tomorrow. I'll just leave that up on the board. Which one of those will work?
law of cosine?
Yeah, law of cosines will work, right? We'll just call this C because it has to be opposite this angle, right? So we'll call that C, and then we'll call this A and B, right? So now we just do the law of sines, cosine, excuse me, C squared equals A squared plus B squared minus 2AB cosine of C. And we need to get C all by itself. So we're going to take the square root of both sides, right? We've done this several times before. And then you plug in all your numbers. We're going to call that 100 squared plus 80 squared minus 2 times 100 times 80 times the cosine of 22 degrees. And whatever you get is the answer. You guys all solve it, I'll solve it, and we see if you get the same answer. I do not have the answer key with me. Oops. I got 39.6 if you were doing it to the nearest tenth. Did you all get the same answer? Yeah? All right. So I don't know if you experienced what I experienced, but we've been using law of cosine. We haven't actually used the law of cosines for a while. And I kind of stared at that and said, wait a minute, do we have enough information? And then I looked over at the board and I said, oh, yes, we do have enough information. We can use this thing we haven't used in a while, the law of cosines. So there's that. Can I move to the next slide?
When I did it, I didn't get that.
You didn't? What'd you get?
Not the right answer. It's like really far off.
Like what'd you get?
0.92.
Yeah.
I like put that whole thing in.
This whole thing in?
Yeah.
That sounds like you have a problem somewhere with the parentheses.
Okay.
So let's, I'm just gonna, because this is, calculator practice is good too. So if you're gonna put it in the calculator, you're gonna have to put in the square root, and then you're gonna have to do an open parentheses. And then you should be able to put in 100 squared plus 80 squared plus, and then you're gonna wanna put this whole thing in parentheses just because you need that minus to carry through, right? Oops, I just did plus when I should have done minus. Minus, parentheses there, and then you go to 2 times 100 times 80 times the cosine of, and then there's going to be parentheses there, and you make sure your calculator's in degree mode, and then that closes that parentheses, then you got to close this parentheses, and then you got to close that parentheses to close off the whole square root. Make sure everything gets put underneath the square root.
Yeah, how do you put it in degree mode? What do you mean by that?
Looks like you have this one right here.
Yeah.
So there's a button that says DRG.
You have to do it before you put in the problem?
Yeah.
Okay.
So if you click that, it's gonna say degrees, radians, and then GRD. So just arrow over to degrees and hit enter. And then it should say DEG at the bottom.
Yeah.
Yeah. And then, of course, we just want to say, does that seem reasonable? Yeah, it does. That's a fairly small angle. Those are pretty long. That's a, that seems reasonable. Sorry if I move. You get it?
Yeah.
Good. All right, next slide. Next slide. Next slide. There we go. Okay, now I gotta figure out how to erase all this stuff. Okay, that erased. Now how do I erase that? Eraser. How come I can't erase that? Alt-Z is not obeying me. Now, how about now? Alt-Z, the programs aren't talking to each other. Oh well, I guess we're gonna have to ignore this. So let's ignore this. There. All right. Well, this is going well, isn't it? There's an isosceles triangle inscribed inside of a rectangle. Each leg is 16 centimeters long. Did I skip a slide? I felt like I had another one before that. Oh, I did. Two people on sailboats look up and see a plane in the sky between them. The sailors know their boats are 300 meters apart. Looks like something we better start drawing. The sailor on one boat sees the plane at a 48-degree angle of elevation. So, right, elevation is above horizontal, depression is below horizontal. The sailor on boat 2 sees the plane at this is great. High production value right here. All right, the sailor on boat 2 sees the plane at a 24-degree angle elevation. What is the distance from the plane to boat 2? So try and draw this out. We got two people on sailboats, right? There's a boat. Boat. There's a boat. Of course, you don't have to actually draw sailboats if you don't want to. But you can, if you like to have fun. We know these boats are 300 meters apart. What else do we know? They're looking up at a plane in the sky. One boat sees the plane at 48 degrees, and the sailor on boat 2 sees the plane at 24. So I'm going to put the plane just like somewhere like right here. I don't know. 24, 48. There's our plane. What is the distance from the plane to boat 2? So we need to find this. What are we going to use to find that?
Law of sine.
The law of sines? Can we use it?
Okay.
We could. How could we use the law of sines? I mean, you
By
could.
finding the
Third angle?
Yeah.
Sure. What's the third angle?
108.
108. It's a 180 minus 24 minus 48, right?
Yeah.
So that's a 108 degree angle.
Okay.
Did you double check it? Is that right?
Yeah.
Okay. All right. So now we can use the law of sines, right? Excellent. So what do I do to use the law of sines?
Do 300 over sine 108, and then equals, I can't see, x over sine 48.
And then I'm gonna, since I'm making this video, I'm gonna list the whole thing out here. And what do you get?
I got 234.4.
You got 234.4. What does anyone else get? Does that seem right to everybody? I'll check it.
That's what I got.
And that's what I got. So it's not a very high flying plane, is it? May I move on to the next question?
Yes.
No? Okay, I will wait. And this video recording will be posted also in all its glory and messiness. I do not know why I can't erase that. Very strange. While you're copying it down, I'm going to see if I can get it to erase that. Oh, sorry. Didn't mean to do that. There we go. I used it before and it erased okay. It certainly is not doing it this time. Oh well. Can I go on now? Yeah? All right. There we go. Let's get rid of the extraneous information again. All right, so now we got an isosceles triangle inside of a square. Each leg is 16 centimeters long and the angle between the two legs is 36 degrees. What is the area of the triangle? Well, I would say the first question is there any information in there we don't need at all?
No.
Does it matter if it's inside of a rectangle? No.
Oh, I thought it gave you like 90-degree angles. And you could use those 90-degree angles for stuff.
You might be able to. Actually, that's a good point.
Oh.
But we don't know the dimensions of the rectangle. So we probably have to use the triangle to find the dimensions of the rectangle, and by that time we would already have gotten the information we need, right?
Yeah.
All right, so let's do this. So we have an isosceles triangle. Each leg is 36. Oh no, that's not right. That's not what it says. Each leg is 16 centimeters. And the angle between the two legs is 36 degrees. And we're supposed to find the area. How are we going to do that? Well, what's the let's just see what we got. We know the formula for the area of a triangle equals what?
It goes to 1/2.
Base and height.
Base times height, right? So we know we're going to have to figure out the height in one direction or another.
Look if it's both right. Wait, hold on.
So we need to figure out a height, right? What direction should we make the height? Basically, I mean, it's isosceles, so it's either going to be there or it's going to be there, right? I mean, it could be there, but those two are the same.
Shouldn't the height go straight down?
You could do it straight down, but then you're splitting that angle up, which is okay, because if you split the cut, it's okay, especially because it's isosceles, so you know you're splitting it exactly in half. So you could put it this way and call that your height, in which case you can find it easily enough, right? If that's your height, then you've got a hypotenuse and an angle and a right triangle. So what's your height, right? Which trig function would that be?
Law of sine.
It's simpler than the law of sine, because if you have a right triangle, you should be thinking of this first, because that's faster, right?
Yeah.
Faster and simpler. So what trig function would I use?
Sine.
Pardon me?
Sine.
Sine? Because because that's our angle, and that's the opposite leg, and that's the hypotenuse, right? So you are correct. Sine of 36 degrees equals the opposite over the hypotenuse. So 16 sine of 36 degrees equals h. (16 times sine of 36). So the height is what? What'd you get? I got 9.4. And since that's 16, 9.4 seems, it's close enough that we didn't make some wonky error, right? All right, so now it's just 1/2 the base times the height. So the area equals 1/2. We chose this as the base over here. 1/2 times 16 times 9.4. And I got 75.2. Hopefully we don't have a lot of discrepancy when we're multiplying three numbers. Yeah. just for giggles, if you had done it this way, then this would be 18 degrees, right? That would be 18 degrees, which would mean this would have to be what?
Oh, 62.
I think 72.
72.
Which we also could have figured out before because it's an isosceles triangle, so those two angles have to be the same. So we could have done 180 minus 36 to find out how much angle is left after this angle and divided it by 2 and found out those angles. That way also. And now we have 72 degrees and we have a hypotenuse, so we could have found this height with trig 2. So there's multiple ways to go about this. And can I go to the next slide? Yeah. All right. And it turns out there's even one more way. And I didn't give this to you, but I'm giving it to you now. I sort of don't feel like I should even give it to you because I just don't want to add confusion at this point, but it is there. So I want you to have it. There is a shortcut formula, and it's on the board over here too. The area of a triangle equals 1/2 AB sine C, which you could prove if you wanted to, but you don't have to. So if you had a triangle, let's just do it this way also. So that's 36 degrees, right? And the legs are 16 centimeters long each. And it's asking for the area. And we remember that the lowercase letters are the sides and the uppercase letter is the angle. And they're going to be opposite each other, right? So we're going to have A and B and C, and we'll make this angle C. Because it has to be, if that's A and B and that's C, then that has to be the angle C. And that's the angle we know, so that's why we want to set it up that way. So you could also solve it like this. 1/2 AB sine C equals 1/2 times 16. I could write 16 squared, but I'm just doing this just to be clear. Sine of 36 degrees. And if you run that through a calculator, you will get just about the same answer, depending on how many decimal points you use. Same answer. So you can either use the tools you already have, or if you remember this, you see a problem like this, you can use that if you want to. And I'm sorry I didn't give it to you sooner, but obviously you already had the tools at hand to solve that without using that shortcut. What time are we getting here? 31? 34, right? 34. Okay, good. We're all right. Okay with that? I can move on? All right. Clear everything and go to the next slide. Oh, great. Can I select that? No. I guess the zoom controls the touch more than the. All right, well, anyway, so we have this, we already did this once, we're just gonna do it again, proving, and you will have the, I just pulled this question off the test. You have to be able to do this So why mess around and say maybe this, maybe that? So you'll have the possible different things up there, and it's a chart you have to fill in. So if we're starting with these two triangles, these two right triangles here. Oops. Starting with these two right triangles here, that one and that one. Prove the law of sines. And we start out with the given, right? So step one is going to be, oh, I hope I have my notes on this. It fills in half the chart for you. Uh-oh, we're going to have to go on the fly. I'm not a fan of that. All right, okay. So the first one is going to be, without the half of the chart filled in. Okay, so the first one is going to be sine of A equals H over B, and sine of B equals H over A. Right? The sine of that angle is H over that, and the sine of that angle, sine of B, is H over A. I can't see that, that's why I'm having trouble. That's B right there. That's the hypotenuse. There's the hypotenuse. So the sine of that angle is the opposite over the hypotenuse. The sine of that angle is the opposite over the hypotenuse. And that one is the definition of sine. Then 2, we're going to go B sine A equals H, and A sine B equals H. And what's that going to be? What property? What did you do to get that B to move over there?
Multiplication.
Yeah, exactly. You multiply both sides by the same thing, right? So that's going to be the multiplication property of equality. Multiplication property. All right. And now we have B sine A equals H and A sine B equals H. So now, because of this, because those both equal H, we can say that B sine A equals A sine B. And what property would that be? Say the word and you'll get it right.
Translative.
What?
Transitive.
Transitive.
Yep. Ribbit.
And 4. We're going to have sine A over A equals sine B over B. And what's that going to be? How'd you get that B back over there?
Division.
Division, property of equality, right?
It's computer squared.
All right. So that's that. Sorry about that. And, like I said, I just cut and paste that right off the test. So, can I move on? Is that enough? Anybody saying stop? No, nobody's saying stop. Okay, good. Let's see what else we got. I'm not sure. That might be the end of the review. We'll see. Okay, that's on mouse. That's on mouse. I think that's the, oh, yeah, that's it. Okay. Well, that pretty much covers everything. And you guys have been doing this a while. And Most of you have been doing pretty good, so I think you'll do well on the assessment tomorrow. I'm not concerned. Any questions on anything? No? All right. Well, then